Good evening everyone. Today we're going to speak about slow changing dimension or slowly changing dimension, and we are going to use the store procedure to show how to implement such very important concept in your real life database. Most likely if you're having interviews for a data analyst, business intelligent developer, or like even a senior position as a data analyst, you most likely will be asked about slowly changing dimension. Why? Because it's very critical concept in database design. So from its name, slowly changing, so it's a dimension or a table that is descriptive table that have an info about employee or a customer or a product that not change very often. So the changing is happening there slowly. For example, it could be the address for employee or address for your customer, or a product type. You are adding a new product. Usually you will not add new to product every time. So over the time your product change, your address change, but you won't keep the history for the transactions. And could be that you won't keep it, or maybe it's not so important, or it's very critical, based on the case you have in hand. Today I will show you the three types that you need to know. Type 1, you don't need to keep the history, so you will just more focus on the last info, the most current info in your database. In that case, you don't have any history. Second type, you're trying to keep a history with accurate start and end, and by that case you will add rows, and I believe this will be the most common question you will receive for that type, and that's actually also in real life will be the most common type you will use. The limited history, that means you are only interested to keep the current and last, but you don't want to keep the whole historical data that have been updated. It could be for something like you are interested to keep new people who are changing their names. Usually people after married in some countries, they change their family name, and in that case you want to keep the last one and the new one. Usually you will not change your last name frequently. Usually women after marriage, they change the name once. Hopefully they not get divorced and not change it again. And by this way, type 3 could be very useful. Let's move to dive into type 1. So as we said, there is no history keep, and old value is replaced with a new one. It's very good when you are fixing typo or you're doing update. I will show you one example that we'll use for the whole cases, so it will be very easy for you to can understand the difference. We have one lady called Alicia. She work in sales and she have employee ID 1. If she moved to marketing, we are in type 1. We will just create employee ID 1, Alicia name, and the department will be marketing. That simply is type 1. What is type 2? Type 2, as we said, we will add more rows, and to do that we will need to create a history. To create a history, we'll put a start date and end date, and still we need to know which row is active one that we can use for our reporting for HR. So that's why we will use a column called is current. It means this is active or not, and it's binary column that it will be 1 in case it's active, 0 it will not be active. So we have the same lady, Alicia, sales, and start date first 23, she was in sales and she didn't move. Then we changed her to marketing, then we closed end date for the sales 1st of August 24, and we open marketing start date 1st of August 24. At this time is current. In the old row for the sales became 0 because it's not active anymore, and for the new row became 1. This is very important and critical if the HR department asks you to provide them about the progress or the development of employee. By this way you can provide them and answer them about people who have changed the last 2-3 years, people who are like have some kind of promotions, but at the same time you have the control over is current. That means also you can filter your table and get the new data without a problem. Type 3, as we said, we will add column. So of course it's not the best option when you are working with a big history. That's why we call it, it's a limited. You can make only one change, two change. You can make it like a previous, -2 previous, -3 years, -4 years. Let's say a company have a policy to keep data only for last 5 years. For changing address for employee, they don't have like any requirement for more years. That's why we'll create 5 rows and columns, and that by this way they have the current, then previous one, previous two. Using same, Alicia moved from sales to marketing, so we have current and previous, sales and null. Then once she moved, it became current, became marketing, and previous department became sales. Today we are more interested in showing type 2. As we said, it's more practical. Let's go to the example and show how we can use the store procedure to achieve type 2. And okay, so here is our table. We create a table called dim employee, as every time, same table actually, but with adding employee surrogate key. That is the case because when type 2, as we explain, for example, Alicia, when we showed the example before in slide, it was having more than one row. So of course the ID for Alicia will not be unique anymore. So we need a primary key. That's why we're creating our surrogate key as a primary key, employee SK. And then we add a start date, end date, and is current to track the history. Then we added these two people, which Alicia and Bob. Just for simplicity, we use only 2 rows to show you what we want to achieve here. Let's write our store procedure from scratch and show you how it goes. Okay, let's create our store procedure. Let's say create proc, and then for this time we will create like update dim employee, and we will need to define our parameter. For changing this kind of data in the employment table, we will need to update the employee ID every time, right? We change the data, and we'll need to also update the first name and the last name. This was the columns that we have. We are trying to create now as a parameter, so it will be like a dynamic update for the table. And then of course our target is like to update the department. Okay, and then after that we will be able to start our store procedure, but we need to define the data type. So let's say this will be like we will use. Okay, so the parameter is already defined. Now we need to start our procedure. Start it as every time with as, and then we begin the procedure. Okay, and then after for best practice, usually you put something called set no count on, and this will help that we not get this kind of message that ask you for how many column have been, how many row have been affected by procedure. Usually you can do that. It will save you a little memory in the best practice in implementation. Then we declare the current department, because this is our target, right? Like current department. And we will use the same type of data, same as department, because that's what we will use for comparison, right? So it must be matching the data. If you not match the data type, it will be really a challenging situation. So we check if the employee if exists or no, right? Because this is the first step. If not exist, we will enter. Okay, so we set already the current department equal to department from dim employee. This is our table. Okay, and then we now need to use the condition to check if the employee ID is matching the same as employee ID. Otherwise it's not the same person, so we will use add, and then now the parameter, because now we want to add the employee ID, right? So you are comparing if the department is the same, if the parameter is matching with what we have, and is current is equal to 1. This means this is the active employee. So now case number 2. Okay, if employee don't exist, what we will do in this case, if. So we will use the same concept. If current department is null, so you will check that simply. If it's null, what we will do if it's null, we want at this time to do insert. Okay, so we will begin our new condition under if, and then we do insert. How we will do insert? Exactly same like this. You can take that one and you can go here and add it. So you are doing insert in the table, but instead of entering value like as we did last time, this time we will enter the parameter. So we will say values equal to parameter. So all the parameter we entered up, we enter them down here, except for these three values. Why? Because this man not exist. So the end date must be null. Current, it will be 1 because this is the active value, and then get date, this should be the today date because that's the day we enter the data. Okay, then of course you need to end it, and then else to start, because we are, don't forget, we are still in if condition. So begin, we will start the second part, or a second case, third case, sorry. It's like if department is the same. If dep is same, then in this case you just, I want you to return for me is no change. Now we go for then enforce. We need to now, this is the most important, this is actually the second type change. We want to close the old record and update a new row for Alicia. So we will do update dim employee, right? This is our table. Then we will set, you want set what? The end date. You want now the end date in the first row from Alicia to be equal to get today date, get date, okay? And then after is current, it became not is current, right? Because like it now as it became inactive. So we want to change is current to make it inactive. So we make it equal to 0. This means we hold the first row, we close the first row in Alicia when employee ID, okay, is equal to the parameter of employee we update. So employee ID and is current date. Okay, then last we will do insert for this kind of updated employee. We will do exactly the same insert. Just take it. So we already updated the old step. Now we will do, you can take it, insert the same. Why? Because as you can see, we did the update. This is will be the Alicia old record here. You see Alicia. So this one became 0. End date we already set to the day date. And now we did insert for the new row. This will be the marketing. So we add the same data with parameter. We make it active. That's why we add 1. Then we end to close the procedure and to close the if statement. And then we can run it. Okay, as we said before, that to run the store procedure, you need execute. I added here like 4 scenarios to check, but I believe the most important one will be changing department. Let's run it for Alicia, and we already run for her. Now we can call again the same table. You can see now Alicia Smith, she was in sales. We added for her end date. We updated the end date. Same, this was the first part we talk about in the column, in the code. In the third case, and is current, it became updated into 0, right? This is the update we did in our store procedure. Then we did insert in the store procedure. You can see Alicia Smith, she is in marketing, and she start date, we add the get date. It's exactly like same as a new employee, but we added a new employee in marketing, and then it became an active. By this way, we've been able to achieve the slow change dimension type 2. What if we have a new employee? Once you execute that and then run it again, you'll find it's already updated automatic. You have Carl Lee from finance, and you can see that current is that one because he's employee, so this is the one active. Of course, if Carl change his department, it will follow the same logic as Alicia. I added Carl Lee CEO. You can see the same change like Alicia. This means it works. Good evening.